Hello, and welcome to this presentation related to solving problems involved with an arithmetic progression, stated as AP for short. Here's a presentation overview. This slide shows the two formulae we'll be using throughout the presentation. We introduce the formula for an arithmetic progression. The nn is equal to a plus n minus 1 times by d. Here's the nomenclature we'll be using, where A denotes the first term in the series, D the common difference within the series, and N the number of terms in the series. We will also use the formula related to the summation of an arithmetic progression, and that's shown here. Sn is equal to n divided by 2 multiplied by, in the bracket, 2a plus n minus 1 times d. And here are the approximate start times related to an outline of the formulae. Presentation overview continued. Then we have an array of tutorial exercises. Exercise 1a through to 5a shown here. Answer stated in the brackets on the right hand side. And here the approximate start times related to exercise 1a through to exercise 5a. Tutorial exercises continued. Exercise 6a and 7a. 7a is a descriptive question. Answer stated here. And here are the approximate start times related to exercise 6a and 7a. Presentation overview continued. And here are some further tutorial exercises for you to attempt exercise 1b through to 4b. And again, all answers are stated on the slide. And here are the approximate start times for exercise 1b through to exercise 4b. Presentation overview continued. The presentation concludes with considering applications of arithmetic progression. And the application given here is spindle speeds of a drilling machine, which form an AP series. And at the very end of the presentation, there are some tutorial questions for you to undertake at your own pace. And here are the approximate start times related to these two sections. Arithmetic progressions have a common difference between successive terms. For example, 1, 3, 5, 7, 9, etc. is an AP series because it has a common difference of 2 between each of the terms. So 1 add 2 gives me 3, 3 add 2 gives me 5, 5 add 2 gives me 7, and so on. This next series of 0, 8, 16, 24, 32, etc. is an AP series because there's a common difference of 8. Add 8 to each term, you get the next term in the series. This fractional series here is also an AP series. A quarter, a half, 3 quarters, 1. There's a common difference between each term of a quarter. We add a quarter to one term, we get the next term. This is a decimal series here, 1.2, 1.5, 1.8. Again, the common difference is 0.3. Adding 0.3 to each term, we get the next term in the series. This series here has a negative common difference, 6.1, 4.7, 3.3, etc. has a common difference of minus 1.4. If we take 1.4 from the preceding number, we get the next number. And in algebraic terms, a plus d, a plus 2d, a plus 3d has a common difference of d. If we add d to each term, we get the next term in the series. So an arithmetic progression series can actually be written in this form. nn is equal to a plus, in bracket, n minus 1 multiplied by d. That's the AP formula. A is the first term in the series. D is the common difference in the series, and n is the number of terms in the series. The capital NN is the actual value of a term n in the series. Example 1 illustrates use of the formula. In this particular series, we're asked to calculate the 5th and the 10th term. It's an AP series. We can see that from the common difference of 1, 3, 5, 7. We can see the common difference is 2 in each of the terms here. Now we're asked to find the fifth term, but we can clearly see the fifth term in this case is actually 9, and we're asked to find the 10th term, which would be the next term in the series, which we can see would be 19. But I'm going to use the formula just to show you how it works. The equation we're using is nn, that's the value, the nth value of the term in the expression, is equal to a plus n minus 1 times d, where a in this case we can see is 1 from the series, d is equal to 2. It's always the second term take away the first term if you're not sure, but we can clearly see it's 2 in this case. And so now we can find the 5th and the 10th term. All we do now to find the 5th term is make the little n value is 5. So in the equation I'm trying to find big N 5, that's the actual value of the 5th term in the series, and that's equal to, in this case, the first term 1 plus the n take away 1, which is 5 take away 1, all times by the common difference, and that equals to 9, which we can clearly see the 5th term is 9 in this case. For the 10th term, I simply put the n value now little n of 10, so I'm finding the 10th term in the series, and that's 1 plus this time 10 take away 1, all times 2, and that's 19. And again from the series above we can see that's correct. Example 2 is going to require us to rearrange the equation to find this particular solution. So it says in the question, which term in the series is 19.1? So we're given an arithmetic progression. We can see it here is because 1.5, 2.6, 3.7. The difference between them is 1.1. We're adding 1.1 to each term here to get the series. So from the equation nn is equal to a plus n minus 1 times d, we need to rearrange the equation this time to find the value of n, because we want to know what number is it in the sequence. Is it the 8th term, the 9th term, whatever? That's what we're trying to find here. So again, notice that the a is equal to 1.5. A is the first term in the series. The value we're trying to find this time, the nn, is 19.1. The d in this case is going to be 2.6 take away 1.5. That's the second term take away the first term, is equal to 1.1, which we can see from the question. So all I'm going to do now is put those values into the equation and rearrange for n. So on the left hand side the nn is 19.1, and that's equal to the a, which is 1.5, plus n minus 1 in brackets times by the d, which is 1.1. Simply taking 1.5 from both sides, I get 17.6 is equal to 1.1 times n minus 1 in brackets. I then divide both sides by the 1.1, and then I add 1 to both sides. So n is equal to 16 plus 1, which is equal to 17. So the 19.1 value will be the 17th term in the AP we're given. Sometimes we're asked to summate an arithmetic progression, and there's a little proof here which I'll leave you with to show how the equation in the bolded box here is defined. I'm going to go straight to the equation, but I'll leave you to look at the proof above should you want to follow that through. The summation of an AP s suffix n here is the n divided by 2, the number of terms in the series divided by 2, multiplied by, in brackets, 2 times the first term, 2 times the a, plus the number of terms in the series n take away 1, all times by d. So the nomenclature is the same as in the previous questions, so we're a different formula here because we are summating the solution here, not finding a particular term in the series. Example 3 shows us an illustration of how to sum terms. So in this particular question it wants us to sum the first 8 terms in the series of 0, 8, 16, 24. Now we can obviously add these up on a calculator or mental arithmetic if we want to, but I'm going to use the formula here to show how it works. So again, looking at my question, it says sum, so I must pick up the correct equation. It's not the nn equation this time, it's the Sn equation. So Sn is equal to n divided by 2, open brackets, 2a plus n minus 1 in brackets times d, and I close my bracket. Okay, so I must make sure of my bod mass here when I do the calculations. Now looking at the AP given, I've got a is equal to 0, the first term, d is equal to 8, the common difference between each term is 8, and the number of terms I'm summating, in this case little n, is equal to 8. All I do now is put those values into the equation, so S8, summing the first 8 terms in this case, gives me 224. Example 4 here is an illustration of how we sometimes have to rearrange the summation equation.
So in this particular question, the sum of the 7 terms of an AP is given to us, and it's 35. The common difference, D, in this question is given to us, and it's 1.2. We've got to find the first term in the series. We've got to find the value of A. So using my summation equation here, because that's what the question asks us to do, summation of an AP is Sn equals to n divided by 2, and in brackets 2 times A plus the n minus 1 times the D. So I know in this case that the summation of 7 terms, S7, was 35. Under the number of terms in the series, because it's 7, so n is equal to 7. The common difference is given in the question, D is equal to 1.2. All I do now is put those numbers into the equation. So on the left hand side my summation is 37, my n divided by 2 is 7 divided by 2, 2 times A, I'm looking for A so I don't know A at the moment, and little n is 7, so 7 take away 1 in the bracket, times by common differences 1.2. Just simplifying that equation, do some number work in the next line, and same with the next line, just simplifying the numbers here, I get 10 is equal to 2A plus 7.2. All I do now is take the 7.2 from both sides to get 2.8, and then I divide by the 2 to get the A. So the first term in the series is 1.4. I just encourage you to go back and have a look at the arithmetic there and make sure you understand your BODMAS process. Exercise 1A. This is basically a question that just simply involves us using the NN equation. So we got to determine the 9th and the 16th term in the series of 2, 7, 12, 17, etc. Again, we would need to check, is it an AP? Well, I think it is, because if we add 5 to 2 we get 7, if we add 5 to 7 we get 12, it looks like an AP. We got asked to find the 9th and the 16th term in the series, so that's the value of the 9th and the 16th term, so that will be the NN equation we're using. So NN is equal to A plus n minus 1 times the D. From the series given, A, first term is equal to 2. The common difference is always the second term take away the first term. We can see that's 5 in this case. So part 1, we're asked to find the 9th term in the series, so little n is equal to 9. All I do now is put the values into the above equation to find the value of the 9th term, the NN value. So 2 plus the 9, take away 1 inside the bracket, times by the 5. Just be careful of your BODMAS here. Working the BODMAS through, the value of the 9th term is 42. Continue exercise 1A. Here we're asked to find the 16th term, but I will let you do that, although the solution is on the slide. The NN value should be 77. Exercise 2A here. In this particular question we're given the value of a term in the series. The value is 22, and we need to find where does that occur in the series. What's the n number, if you like, of that term in the series? Is it the 10th term, the 20th term? That's what we're trying to find. So we check the series, 2.5, 4, 5.5, 7, and it's an arithmetic progression because there's a common difference between each term. In this case the difference is 1.5, 2.5 add 1.5 is 4, 4 add 1.5 is 5.5, so we've got an AP here. So the formula we're going to use is the NN equation here because we're given a value of NN, 22 in this case, and we've got to find the value of little n, where does it occur in the series. So from the question, NN is equal to 22. A, the first term in the series, we can see is 2.5. The common difference is always the second term take away the first term, so 1.5. So given the above equation for NN, I'm going to rearrange the equation. So the first thing I do is to take A from both sides of the equation. So NN take away A is equal to n minus 1 times D. Next step, I'm going to divide by D. So NN take away n divided by d on the left hand side is equal to n take away 1 on the right hand side, and now all I do is add 1 to both sides. So little n is equal to nn take away a divided by d plus 1. All I do now is put my values into the expression. So nn we're told was 22, a, the first term in the series, was 2.5, so I take away the 2.5 and I divide that bracket by 1.5 and then add plus 1. Just be careful of your BODMAS here, make sure you follow the process through correctly. It should give you n is equal to 14. Thus 22 is the 14th term in the series we were given. Exercise 3a here is a summation problem. We've got to summate the first 12 terms in a series. So the series is 5, 9, 13, 17. There's a 4 common difference between each term here. So it's a summation problem, so we need the Sn equation this time, not the Nn equation, using the Sn equation, which was n divided by 2 times in brackets 2a plus n minus 1 times the d. So from the question, the number of terms we're summating is 12. The first term in the series A is 5. The common difference, second term take away the first term, is 4. All I do now is put those values into the S equation and I summate the first 12 terms. So S12 in this case, if you follow the arithmetic through, will give you 324. Exercise 4a here, we're asked to determine the sum of the first 21 terms in the series 3.5, 4.1, 4.7, 5.3. Common difference there is actually 0.6. Now we're asked to summate here, so we must pick up the right equation. That's the Sn equation. The Sn equals to n divided by 2, 2a plus n minus 1 times by d in the brackets. In this case we're asked to sum the first 21 terms, so n is 21. We can see the first term in the series A is 3.5. The common difference, the second term take away the first term, is 0.6. Again, putting those values into the Sn equation gives us an S for the 21 terms summated of 199.5. I'll let you check the arithmetic. Exercise 5a, again we're a sum equation. We're asked to sum the first 50 odd numbers in a series. So we have to define the series this time, it's not actually given to us. But the AP for odd numbers would be 1, 3, 5, 7. Okay, so A in this case would be 1. The common difference we can see is 2. 3 take away 1 is the 2. And we're asked to summate the first 50 terms, so n is equal to 50. So using the Sn equation, because we're summating the first 50 terms, I use the n upon 2 times by 2a plus n minus 1 times d in brackets, that equation. I'll let you put the numbers in. You should find that the summation of the first 50 odd terms is 2,500. Exercise 6a here. Slightly more complicated problem that will involve simultaneous equations. We're given the sixth term in the series is 17, so n6 is 17, and the 13th term in the AP is 38, so n13 is 38. We've got to find the 19th term in the series. So from our AP equation, nn is equal to a plus n minus 1 times by the d. Now the problem with this particular question is we have two unknowns in that equation. We do not know the first term a, and we do not know the common difference d. So we're going to generate two equations and we're going to find the values of d and n a. Consider the sixth term. We know that n6 is equal to 17. That's equal to a plus little n, which would be the 6 for the sixth term, take away 1 times by the d. The a and the d we don't know, but we do know the nn, 17, we do know the little n is 6. Just simplifying that equation, that 17 is equal to a plus 5 times d. We've called that equation 1. Now consider the 13th term. The n13 in this case is 38. Still don't know the a, but we know little n is 13 now, so again we can rewrite an equation, and we get 38 is equal to a plus 12d this time, and that's equation 2. So I've generated two equations here. To solve the equations, it's now equation 1 take away equation 2, and I can see that will eliminate the a value from the expressions. So on the left hand side, 17 take away 38 is minus 21, 6d take away 13d gives me minus 7d. One unknown in one equation, I can now solve that. So rearranging that, 7d is equal to 21, or d is equal to 21 divided by 7, which is 3. I've now got my common difference, d. Continuing exercise 6a here. Now we're going to back substitute the value of d, which we found in the previous question, it was 3, into equation 1. So equation 1 was 17 is equal to a plus 5 times d. I know that d now is equal to 3, so I can work out the value of a. A is 2. So the first term in the series is 2. Now I can go back to the original question and I can find the 19th term by using my nn equation. So n19 is equal to the a, which is now 2, plus n, little n, which is 19 take away 1, times by the common difference, which we found was to be 3. Again, doing the arithmetic on that, the 19th term in the series is a value of 56.
Here's exercise 7a, a descriptive problem. A tunnel is to be drilled through rock for a distance of 1,000 meters. The cost of drilling the first 10 meters is £350,000, with an increasing cost of £3,000 per 10 meter length of tunnel. Assuming an AP, we've got to calculate 1, the cost of drilling the last 10 meter section of the tunnel, and 2, the total cost of drilling the entire tunnel. Answers shown in the bracket here. I'd encourage you to stop the presentation and attempt exercise 7a, but the full work solution is shown on the following slides. So exercise 7a, commencement of the solution. So reading the question, we know we have an AP. So the first term in the series relates to the cost of drilling the first 10 meters. First number in the series, labelled A here, is £350,000. Note the number of terms in the series, lowercase n, with the total length of the tunnel, 1,000 meters, but divided by 10, because the costs are per 10 meter length. So the number of terms is 100. The common difference in the series D is £3,000. Showing the first three terms, first term is £350,000, second term £353,000, third term £356,000, etc. Common difference £3,000. Exercise 7a, solution continued. Let's repeated the value of A, N and D from the previous slide and the first three terms of the arithmetic progression. So part 1, we're asked to find the cost of drilling the last 10 meter lengths of the tunnel, denoted as N100. So here's our formula for the arithmetic progression. We insert the values for A, N and D, and evaluating the cost of the last 10 meter lengths is £647,000, or that could be written as £0.647 million. Exercise 7a, solution continued. Again repeating information from the previous slide. Part 2, we're now calculating the cost of drilling the entire tunnel, denoted S100. Now we're summating all 100 terms here. So using our summation formula and inserting the values, the total cost of drilling the 1,000 meter long tunnel is £49.85 million. Exercise 1D here. We're given in the question the sum of 25 terms in an AP is minus 525. We're given the common difference here, the D value is minus 2. We've got to find the first term, that's the A value of the series. Now this is a sum problem because we're given in the question the sum of the first 25 terms. So I'm going to use my summation equation, the Sn equation here. That's equal to n divided by 2 in brackets 2a plus n minus 1 times d. Now in this question I'm given the sum of the first 25 terms. I'm told it's negative 525. I'm given a number of terms, obviously it's 25 that I've summed. The common difference in this case also given, d is equal to minus 2. So I have to find the first term in the series. That means I have to rearrange the equation for A. So putting the terms into the equation, on the left hand side the S25 is minus 525, on the right hand side n divided by 2, 25 divided by 2, in brackets 2 times the A plus the n minus 1, n25, take away 1 times by the common difference is minus 2. From there on in it's basic arithmetic. I'll let you look at the arithmetic, try and follow that through, but you should find that A is equal to 3. So the first term in the series is equal to 3. Exercise 2b, we've got three numbers in an arithmetic progression here. Their sum, in other words when you add the three numbers up, is 15, and their product, in other words if you multiply the three numbers together you get 80. We've got to find what these three numbers actually are. There's a hint given to us here to let the three numbers be written as x minus d in a bracket, comma x plus d in a bracket. And again that follows an AP common difference is d in this case. We're going to generate some equations and solve here. So let's consider the three summated numbers here. So from the above format that will be x minus d plus
the x plus the x plus d. Those are our three numbers. They're equal to 15, we're told. Now, I don't need the brackets in this case. If you look at the terms here, if you take the brackets away in this case, so x minus d plus my x plus d equals to 15. If you add up the x terms together, you'll get x plus x plus x, you'll get 3x, and you can see that the minus d and the plus d cancel. So 3x is equal to 15. Simply dividing both sides by 3, I get x equal to 15 divided by 3, which is 5. Exercise 2b continued here. We're now going to look at the three numbers multiplied together, and that is the product of the three numbers, and we're told that value is 80. So in this case, we'll have x minus d in a bracket, times by the x plus d in the bracket. We know from the previous calculation that x in this case is 5, so I can put a 5 wherever I see an x. All I do now is expand the first bracket with the 5 to get 25 minus 5d, and that leaves me to be times by the 5 plus d equals to 80. And then I've got binomial bracket expansions here for the next line, and I'm simplifying on the further lines. I'm going to let you look at the expansion. Don't forget it's a binomial expansion, so 25 times the 5 and 25 times the d minus 5d times the 5 minus 5d times the d. Be careful how you do your expansion. However you do your expansions, just take it nice and carefully there, and you should get down to a value eventually of d squared is equal to 45 divided by 5. When you square root both sides, there are actually two solutions here. It's actually plus or minus 3. I'm just going to look at the positive solution here, the 3. So in other words, my AP series would be x minus d, x plus d. So in this case, x is 5, take away the d, which is now 3, so that will give me 2. 5 is the x in the middle term there, and then x plus d, that would be 5 plus 3. That would give me the 8. So my numbers in my series using the positive value of d would give me 2, 5 and 8. Exercise 3b. Let's be a bit careful here with the information given and how we're going to analyse this problem. We've got to determine the sum of all the numbers between 3 and 207 inclusive which are exactly divisible by 3. So we have to put our AP series together here. So 3 is the first term, obviously divisible by 3, then 6 would be, 9 would be, 12, 15 and so on up to 207. That's our series that are divisible by 3. Now in the first part of the question I'm going to use the NN equation. Even though it's a sum problem, I'm going to have to use the NN equation to find the number of terms in the series, because that I do not know. So NN is equal to A plus N minus 1 times by D. I do not know the N, little n value in this particular case, but I do know that the first term in our series we can see is 3, and I know that the last number in the series, the NN, is 207. The common difference is the second term take away the first term always, so the common difference we can clearly see is 3 in this case. Exercise 3b continued here. So using the NN equation, I know on the left hand side the last term in the series is 207. The first term in the series we can see is 3, and the common difference is 3. So I'm going to rearrange this equation to find n. All I've done on the next line is divided throughout by 3 to get 69 is equal to 1 plus n minus 1 in the brackets, and then I've expanded my brackets here, just taken my bracket away. I don't need the brackets here. I can see that n is clearly 69. The 1 take away 1 disappears, so n is 69. Now I can use my summation equation and I can summate all the terms, which I know now there's 69 of them. So my little n now will be 69 in this equation. My a we know is 3 and my d we know is 3. The rest of it is basic arithmetic. I'll let you look at the arithmetic, but summing the first 69 terms in our series should give us 7,245. I suggest you check the calculations. Exercise 4b. We're given the first, the 12th and the last term in an AP. They are 4, 31.5 and 376.5 respectively. We've got to find the number of terms in the series, that's the little n value, summation of all the terms in the series, and the 80th term in the series. So from the arithmetic progression formula, NN is equal to A plus n minus 1 times D. We know that A is equal to 4, the first term. The 12th term N12 is equal to 31.5, and the last term, Nn, don't know how many terms are in the series, so Nn is equal to 376.5. We have to find the value of little n, and we have to find the common difference d. Exercise 4b continued. Let's consider the 12th term only. The N12 is 31.5 in this case. We know the A is 4. We know the N will be 12. So from this equation, we can solve for D. So again, putting the numbers in and doing the arithmetic, we find that D is equal to 2.5. I'll let you look at the arithmetic. Consider now the last term in the series. We're told that 376.5, that's equal to A plus the n minus 1 times the D, which is 2.5. So rearranging this, if I subtract 4 from both sides of the equation, I get 372.5 on the left hand side is equal to n minus 1 times 2.5. Dividing both sides by 2.5, I get 149 is equal to n minus 1. So we can see that the n is equal to 150. That is, the total number of terms in the series is 150. Exercise 4b continued. We're also asked to summate all the terms in the series. So now we know there's 150 of them. We have to summate them, so we have to use the Sn equation. So pick up the appropriate equation here. Sn is equal to n divided by 2 in brackets 2a plus n minus 1 times by d. We have all these terms now. We know little n is 150. We know the a is equal to 4, the n is equal to 150, and the d is equal to 2.5. The rest of it is arithmetic here to work out the total values of all the terms. So Sn is equal to 28,537.5. If we want to find the 80th term in the series, which is the last part of the question, the N80, we simply go back to our original equation, our Nn equation. This time we put in 4 for the A, the N is going to be 80, and we know the D is 2.5. Again, doing the arithmetic on that, the 80th term in the series is 201.5. I'll let you check the numbers there. Okay, we're going to look at an application of the arithmetic progression here related to spindle speeds of machine tools. When designing a machine tool, the highest and the lowest spindle speeds are often determined by the extremes of the workpieces to be accommodated. If the cutting speed, symbol S, of the machine is known, then there's a formula we can use to work out the spindle speeds, symbol N. And that formula is spindle speed N is equal to 1000 times S, the cutting speed, all divided by pi times the diameter of the workpiece. And that's a standard formula. So we can develop a series, an arithmetic progression, based on this formula for cutting speeds.
Example 5 provides an illustration of how we can develop lathe spindle speeds in terms of an arithmetic progression. A lathe is to have 6 spindle speed N arrangements in an AP and accommodates work ranging from 12 mm to 250 mm in diameter. Diameter is symbol capital D. Allowing for a 25 meters per minute cutting speed, symbol capital S, we've got to find these spindle speeds. So in this case, our arithmetic progression will consist of 6 terms, N1, N2, N3, N4, N5 and N6, each representing a spindle speed in RPM, revolutions per minute. We're informed in the question that the cutting speed, capital S, is 25 meters per minute. The question also states that the minimum diameter of work to be machined, labelled as D1 here, is 12 millimeters, and the maximum diameter of work, labelled D6 here, is 250 millimeters. So, what I've termed step 1, we're going to calculate the first and the last terms in the arithmetic progression. Just a note for reference here, the minimum spindle speed is based on the largest diameter. So let's consider the minimum spindle speed. I've labelled that as N1 here. So from our formula on the previous page, shown here, the N1 is equal to 1000 multiplied by spindle speed S, and for the minimum spindle speed, that's divided by pi multiplied by D6, D6 being the maximum diameter of work to be machined. Inserting the values, D6 here is 250 millimeters, N1 evaluates to 31.83 RPM. If we now consider the maximum spindle speed, I've labelled that as N6 here, using the same equation, but this time dividing by pi d1, d1 being the minimum diameter of the work. So we're divided by pi multiplied by 12 millimeters here. So N6 evaluates to 663.15 RPM. So our arithmetic progression, in this case, as we know, has 6 terms. The first term is going to be 31.83 RPM, and the sixth, or the last term, is 663.15 RPM. Sample 5, solution continued. Step 2, we're going to calculate the common difference, labelled lowercase d here. So here's our arithmetic progression formula, and n is equal to a plus in the bracket n minus 1 multiplied by d. In this case, the first number in the series a is actually n1 from our previous slide, so at 31.83 RPM. And the last number in our series, that will be the sixth term in the series, so that was 663.15 RPM from the previous slide. The number of terms in our series n is 6. So inserting our values into the AP above, and subtracting 31.83 from both sides of the equation and dividing by 5, our common difference d is 126.26 RPM. For the final step here, we're going to calculate the arithmetic progression of our spindle speeds. So our AP is equal to, first term A, 31.83. Our second term, we have 31.83 plus common difference D. For the third term, we have the 31.83 plus twice times D. Our fourth term, the A plus 3 times D. Fifth term, shown here. And of course our sixth term we calculated on the previous line. What has happened on the last line is I've stated the AP in terms of integers, so I've just rounded the previous line to show the 6 spindle speeds calculated as an arithmetic progression. In example 5, solution continued. There's a slide again showing the calculations for spindle speeds using the AP formula. Again, all 6 speeds have been rounded to the nearest RPM. And here are some tutorial questions for you to undertake at your own pace. Question 1 through to question 5 shown on this slide. And note the answers are stated in the brackets on the right hand side of each question. Question 5 is quite a difficult little problem, but there is a hint stated in the question to try and help you generate your solution. Tutorial questions continued, commencing with question 6 here through to question 10. Again, all answers are shown in the brackets on the right hand side of each question. And here's the bibliography used to help generate this presentation. Some very good technician engineering textbooks stated here for your reference. And I hope this presentation has been of some use to you, and as always, thank you for viewing.